Okay, ITS 128, 3:30. Sorry about the lateness. Let me share my screen here, and let me open up, find out where we are. Lima. Why is that just being set up now? All right, so we are sharing 128. We are, this is this day, March 14th. Chapter 7. Let's see. Okay, how are we doing with the midterm anyway? Midterm is, I said it was due the 7th. That's okay, so that would be this coming, oh, that's before spring break. Okay, so do I need to extend it? All right, so yeah, let me do that. So why don't I extend it to except until this is the Tuesday after Tuesday after break. Okay, so I'll accept it up until Tuesday after the break. So that way, if you still have problems, you can talk to me then. And let me make this Tuesday after the break also. Whatever. So Tuesday after the break, Tuesday after the break, Tuesday after the break. Ooh. Didn't do that. Okay, post. Okay, so Tuesday after the break. Some people have handed it in already. Well, you got more time, whoever you are. I will tell you what, I'll look at these during the break, and I'll let you know. And if you didn't get everything right, I'll get back to you on that. Make sure that the grade book is, ooh, I gotta assign all these quizzes, don't I? All right, well, all of these quizzes are gonna go up to here. So they're all gonna be assigned, don't worry. They're all gonna be part of quizzes. What are we doing with chapter 7 anyway? Let me go in here. Ooh. Oh no, not here. I'm gonna go here. Arrays. And how far did I get? Oh, call by reference, call by value, array elements, subscripts, working with arrays. That's right, errors in the book. For each, we learned about for each finally. Reading files from an array. Passing an array as an argument. We pass by reference. That means if you pass an array to a method, the method can mess with the array. Whereas normally when you pass data to a method, the method cannot be, the method can mess with it internally, but when the method returns, the data is still as it was before the method was called. Not so when you pass an array. If you pass an array to a method and the method actually manipulates the array itself, when the method is done, the array is manipulated back up with where it was called. Oh, useful array algorithms. Oh, that's right. I remember we talked about this. Useful array algorithms. That's right. We talked about finding the highest value, finding the lowest, sorting and searching. Selection sort, binary search, two-dimensional arrays. Nested, jagged arrays. Lists. All right, so I'm going to switch over to the textbook just because let's see if this works. Vital source. Because I don't trust the slides anymore. And we're in chapter 7. Okay, let's go to selection sort. Oh, swapping. Oh, can I get rid of this? Okay. This is a complete code for selection sort. So start by, we declare a minimum value. Okay, so we declare a couple of variables. The index, okay, so with selection sort, we take a pass through the whole thing, finding the minimum value. And when we do that, we keep track of where we found it and what that value was. That's what these two variables do. And then we also keep track of, let me accept this. Can I just do this? No, it doesn't work, does it? Accept, close, don't ask. So we keep track of a minimum value, and all right, and then we start. There is a. Can I do this? Does this work? That doesn't work, does it? I wish I. There is a. Is this all there is? Okay, here's the swap. Okay, remember the swap. We take in an A and a B, and it actually swaps them. It sets, it creates this temporary variable. It sets A equal to the temporary variable, and then it sets A equal to B. First, it saves A. It saves A into this temporary variable, and then it sets A equal to B, and then it sets B equal to what was saved in A. So that swaps them. The reason that we're using reference variables, the reason we're using reference is because when we swap them down in here, we want them to be swapped back up here where it's called. And right here is where we call the swap, see? So we actually want to swap this array element with this array element. Okay, we actually want to do that. So this selection sort here is, there's an outer loop and an inner loop. So now I can use this pencil thing. There's an outer loop, and then there's this inner loop. And we started the 0th element, and we go one by one up to the top, up to the last element. Okay, one by one. And so let's start with the first one. We start with the first one, and we're going to go through the whole thing. And we're going to find the smallest value, and we're going to find the position of the smallest value. We're going to record what the smallest value is, and we're going to record the position of the smallest value. And so right now, when we start out, we say that the index of the smallest value is at the first element, and the value is whatever the value is of the first element. And then we go through it, starting with the next one all the way up to the top. And we check to see if this next one that we're looking at is smaller than the smallest value. If it is smaller than the smallest value, then we want to record what that new smaller value is. That's what this does. It takes the smaller value, it changes what we did think the smaller value was with the new smaller value, and then we record what index we found that at. Okay, so this thing goes through all of them, and when this thing is done, we're going to have, by gosh, the smallest value and the position of the smallest value. Then we're dealing with the outside loop. So then we swap this newfound smallest value with the starting one that we started at. So if we have like 5, 2, 3, we start with 5, and then we find the smallest value of these, and when we're done, okay, this is index 0, this is index 1, this is index 2, right? These are the indexes, and these are the values. So we're going to start it at this one, and then we're going to go through all these, and we're going to find that at index 1, index 1 is the smallest value, and the smallest value is 2. Okay? And then we're going to swap this one with this one, because this is the new smallest value, and we're going to swap it with this one, and then we're going to end up with 2, 5, 3. Okay, and then we're going to then we're done with this, with the first position. We know that the first position has got the very smallest one, and then we're going to go to the next one, and we're going to compare this one with all the rest of them. There's only one. And we find that this one is smaller than that, so we swap those, and so we end up with 2, 3, 5. So this was a real simple example, but you can see that each time we take a pass through, we're looking at one less position, because each time we find the smallest one, we put it back up at the top again, and then we look at the remaining ones. We find the smallest one, put that back at the top, and we keep on going until we've gone through as many passes as there are elements. And each time we take a pass, it's one less pass than the previous time, because because each time we find the smallest one and we put it up at the top. And so that's how selection sort works. We are selecting the smallest one and putting it at the top. That's how selection sort works. And binary search is pretty important. Here's the pseudocode for binary search. We have an array, we've passed in an array, and we're looking for a particular value. Okay, so we have this variable called first, and we have a variable called last, and we have a variable called position, and we have a variable called found. Found is a Boolean variable. Position is an integer which keeps track of a position. And then we have a first one, a first, and this is a subscript, and this is a subscript. So we start out we start out with where first is equal to the very top, and last is equal to the very bottom. So first is equal to the smallest one, and last is equal to the biggest one, because up at the top it's the smallest one, at the bottom it's the biggest one. So 0 is at the top, the smallest one. Last is at the bottom, it's at the biggest one. And then we keep on doing this until either found is equal to true, and we found it, or until we end up crossing the first and the last, end up crossing each other. Okay, you'll see what that means. Okay, so let me turn this pencil thing back on again. All right, so while found is not true, in other words, while it's not found, and first is less than last. Okay, so we have a bunch of values here, like 2, 5, 6, 9, 10, something like that. And this is equal to first, and this is last. First, last. And so we start out, we set the middle. We have a variable called middle, and we set that equal to the subscript that's halfway through. So this is subscript 0, 1, 2, 3, 4. So there's five elements in this array. So we start out by setting this middle equal to the middle. And so that's going to be this one. This is the middle. And let's say we're searching for 7. Searching for 7. Okay? That's what we're searching for. And 7's not in here, so we're not going to find it. So the first thing we do is we set middle equal to halfway. So middle is equal to this one. It's in the middle between array first and array last. And then we see if middle is equal to the search value. Is 6 equal to 7? No, it's not. So it's not found. So then we set, so it's not found, so it's else. Else, if middle is greater than the search value, is middle greater than the search value? No, it's not. Middle is less than the search value. Middle is 6. Search value is 7. So is middle greater than the search value? No, it's not. So we do this case. We set first equal to middle plus 1. So first is now equal to this. First. First is no longer equal to this. Why? Because what we've done here is when we check to see if 7 is equal to 6, it's not. 7 is bigger than 6. Then we narrow it down. We know it's in the bottom half. So by just doing that one check, we've eliminated half the arrays. So now we do the same thing on this half. So we check the middle. So we go back to here again, and found is still false. So now we set the new middle equal to halfway. Well, halfway is kind of tough. It's equal to 3 plus 4 is 7 divided by 2 is it's going to be 3 again or something. Let's see. Middle is 3 plus 4 is 7 divided by 2 is 3.5. It's going to be equal to 4. Actually, if 3 it's actually going to be 4 because it's going to round to 4, but it doesn't matter. It can be 3 or 4 because we end up then checking 9. Okay, so let's say it's 3. It's going to be 9. So we say is 9 equal to the search value? No, it's not. Is 9 greater than the search value? Yes, it is. So then we set middle, we set last equal to middle minus 1. Well, middle was 3, so last is now going to be equal to 2. So last is now equal to 2. So they've crossed. So last is crossed first. So we come back up here and we say, is first less than or equal to last? No, it's not. So that's false. So we're done. And it's crossed, and found is still equal to false, so it's false. So that's how binary search works. And I think I went over that last time. Okay, how do I get my table of contents back? Okay. And we're in chapter 7. Advanced algorithms. Oh, here's a nice. Oh, this shows how selection sort works. This is a good one. So we start out with 5. We go all the way through, find the smallest one. 1 is the smallest one, so we swap them. So 1 goes where 5 was, and 5 goes where 1 was. And then So this is going to be, this is already in the smallest position. So then we go through all the rest of them and find 2. 2 is the smallest one. Oh, here. Oh, here. So we scan through this one. Okay, we're trying to find what goes in the second position. And so we scan through all these. We find that 2 is the smallest one. So then we swap 7 and 2, and we end up like this. And then we're going to find what's in the third position. So we scan all the way through. We find that 5 is the smallest one. So we swap 5 with 7, and we end up with this. And then we find the smallest one here, and we find that 7 is the smallest one. So we swap 7 and 8. And so it ends up being 7 here and 8 here. And then we scan down here, and we find 8 is the smallest one. So we swap the 8 and the 9, and we end up with this. And so this is how we end up with a sorted array. That's selection sort. This is binary search. We have an example of binary search here. Oh, here's the actual code for binary search. Is that it? Okay, so I may ask you to implement these algorithms, but you'll have the code, so you'll basically have to just implement it. But I'll wait till after the break before I give you my next assignment. Okay, so two-dimensional arrays. Did we talk about two-dimensional arrays last time? It's conceptually pretty simple. We have rows and columns this time, not just a column of numbers or a row of numbers, but columns and rows. And and we refer to them like this, where we have this is the row and this is the column. One is for row and the other is for column. It conceptually doesn't really, I mean, conceptually it matters, but really it doesn't matter if you're doing rows and columns. And in fact, programming languages throughout history have sometimes the first one's been the row and sometimes the second one's been the row. It doesn't really matter. Even when you implement them in the lower level languages, it doesn't really matter because it ends up, being like 6 of one, half dozen of the other. But in C#, the first one is row, second one's column. So this is the elements of row 1 are referenced as follows: row 1, column 0, column 1, column 2, column 3. So it's like this. So this is row. The first one's a row. The second one's a column. This is row 1. This is row 2, column 0, column 1, column 2, column 3, like that. And so let's see. Programs often use nested loops to process two-dimensional arrays. For example, the following code assigns a random number to each element in an array. So we didn't really talk too much about random numbers, but it's conceptually very simple. You have this class, the static class called rand, I think. Oh no, it's not a static. It's a class that you can define. So you have rand. Of course, that makes sense. You'd want to be able to create more than one instance of it. So we have this object called rand. We have a type called random. And so in this code, we're creating an instance of this random type or this random class, and we're going to call it lowercase rand. And the way it works is there's a method in there called next, and it takes a parameter, takes an argument, and what it'll do is it'll return a random number between 0 and 100. And it's not inclusive, so it's between 0 and 99, I'm pretty sure. And so this code here assigns a random number between 0 and 99 to each element. So the inner loop loops through the columns. The outer loop loops through the rows. So we start with the lowest row, and we do column 1, column 0, 1, 2, 3, 4, like that. And then we go to the second row, and it's 1, 2, 3, 4, 5, and third row, and so on. Each time we assign a random number to it. And here we're displaying it out. And we can define two-dimensional arrays, you know, like this, where we actually, the size is implicit in the assignment, and the values themselves are assigned. So this is going to be a 3 by 3 integer, two-dimensional integer array called values, and it's going to assign values like this. 0. This is row 0, row 1, and row 2. And column 0 is going to have 1, 4, and 7. Column 0, column 1, column 2. Like that. So this is how it's assigned. All right. So those are two-dimensional arrays. Here's an example of how you would add up all of the elements of an array. You just have a variable called total, and you can loop through for each row, 0 through number of rows, and then for each column, you just add them up. Summing the rows, here you would you'd want to here you sum up for one particular row. For each row, you sum up the columns. Another exercise might be you have another array called total, and total is just a single dimensioned array, and you could have total 0 will be the sum of row 0, total 1 could be the sum of row 1, and so on. That would be an exercise not like this. Summing the columns, this is it. This is what I was just talking about. All right, jagged arrays are like two-dimensional arrays, except for each row can have a varied number of columns. So whereas in a two-dimensional array, you would declare it like a two-dimensional array, you declare it, where am I? Oh, this is a single. Oops, boy, I really went back far, didn't I? Ooh, I went back way too far. Oh man, sorry. Okay, a two-dimensional array, you declare it this way, where you just put a bracket, comma, close, square bracket, comma, square bracket, like that. Whereas with a jagged array, you do bracket, bracket, like this. So it looks a little different. And so each row could have a different number of columns. So you wouldn't call them columns, you'd call them elements, I guess. And so 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 each row has a different dot length property. So it could look something like this, where this is a jagged array where the first row only has 3 columns, the second row has got 4 columns, and the third row has got 5 columns. And you can kind of imagine different reasons why you'd want a jagged array. It's, you know, and it's all about efficiency. It's all about memory efficiency. A list is a different kind of thing. So here, this is how we declare a list. It's a list of some type, or it's a list of objects. It can be a list of class objects, but here we're speaking of a list of strings. So it's kind of like an array. It's kind of like a single-dimensioned array, except for it's implemented differently. C# implements them differently, and the methods, there are different kinds of methods that are available. An array is implemented in contiguous memory locations. So a binary search makes sense with an array because you can easily identify the middle element. You know that there's 10 elements. You know there's 10 elements in the array, and each array element takes the same amount of size. And so it's easy to, by math, it's easy to calculate what this middle index is, what the value of the middle index is. Whereas a list is not that way. A list is implemented where the next element in the list is stored in the current element of the list. So when you implement a list underneath, the way C# implements a list, the first element of the list contains the value plus where the next element is. And so one nice thing about a list is that lists can grow, and they end up only taking the amount of space that is however many elements there are in the list. So if a list has 10 elements in it, it only takes up 10 elements. For an array, you have to declare a maximum size of the array. So if you want to use an array and you're not sure how many elements you're going to have in the array, you need to declare the size of the array to be as big as you would possibly need it to be. If your program is running and you run out of array space, you have to actually declare a new array that's bigger and then copy everything over. Okay, you actually have to do that. Whereas with a list, you can just keep on adding on to it. So when you have a list, if you want to traverse a list, it's easy to traverse it because you just start with the first one, and then the list itself, the element knows where the next one is, so you go to the next one, you go to the next one. But if you want to go 3 elements down, you cannot just go 3 elements down. You have to go the next one, the next one, the next one. Okay. Whereas with an array, if you want to go 3 elements down, you just take the index of the array and you add 3 to it, and you're 3 down. You've gone 3 down. So binary search is easy to do with an array, but it's hard to do if you have a list. So having a sorted list doesn't really buy you much. But another advantage to a list is if you do need to sort a list, you don't need to do as much exchanging. You only need to change you only need to change what the next element is. So Anyway, so the way you declare a list is you have this word list, and then the type of list, and then this is the name of it, and then you declare it saying it's a new list of this type. So you can initialize a list like this, where you say you're declaring a list and you're calling it number list, and it's a list of integers. And so this new list of integers contains these integers. And if you want to add another integer to the list, you just add it on and it automatically tacks it on. So this is a list of strings, and we're calling it named list. It's a new list of strings. And so when you want to add something to it, you just go like this. You say use this add method to add a new element onto the end of the list. It's hard to insert stuff into the middle of a list because you have to move stuff around. It's actually not hard to insert something into the middle of a list. It's hard to insert something into the middle of an array. If you have an array that's 100 elements long, and you want to insert something in the middle, you have to move half of them down. Whereas with a list, you're able just to change what the next element is. You're able to sort of plunk it into the middle by changing the next pointers is what they call it. But we're somewhat familiar with lists because a list box. We're fiddling around with list boxes with the midterm, and we've fiddled around with list boxes as a form on forms, and the methods that we use list a list box of items. A list box has a list of items, and the methods that we use to add items to a list is the same methods. It's .add and .remove. So yes, when we're able to insert items into a list at particular indexes, it's easy to do. We don't have to move a bunch of stuff around. All right. All right. I think that's enough for this. So when we get back, I will I'll probably have an assignment which compare doing something with arrays with lists, so you can kind of see what the difference is. All right. So are there any questions? Okay. So if you need to see me this weekend, or I mean this next time, I have a key to this place. So if you want to meet, we can either meet up in my office. If it's like one or two of you, we can meet up in my office. If it's more than that, we can meet down here, and we can open it up down here. But you have to get a hold of me first. But I'm not going anywhere. So, and if you'd like me to take a sneak peek at your midterm, I'll do that. You just gotta send it to me. I've extended the due date until the Tuesday after the break, and I did that for my other class, so I felt like I should do that for this class too. You just send it to me in enough time, couple days at least, and I'll take a peek at it, and if there's something that's blatantly wrong, I will just okay. So yes, so someone just, I submitted it to save. Are you able to open it? You submit it to your okay, I'll check. So you can either submit it at the place where you submit your assignment, which is like the midterm, or if you just pop it in your Dropbox too, then tell me, and then I'll go there and look. But yes, I will go in there probably, early next week or maybe this weekend, and I'll see who has submitted midterms. I see that several of you have already submitted your midterms. That's good. You're on top of it. I will check them out, and if there's anything that's not right, I will get back to you and say, oh, it's not quite right, and I'll give you a hint or something on how you can fix it. So that way you get maximum learning out of this. I don't understand your question. I was not finished. That's why I thought it was unlimited. Oh, so would you like me to look at it? If so, email me. You'll email me. Because I don't know who Q is. All right, can I do an emoji? Can I do a thumbs up? Okay. All right. Okay, so have a good is it St. Patrick's Day on Sunday? Okay, well, don't get too sick. You probably don't do that anyway. My old age, I don't do too much of that anymore, but St. Patrick's Day is going to be. All right, so thanks for watching, and see you after. If I don't communicate with you during the break, I will see you after the break.